Welcome to the Design Hub of Heavy Machineries. Today we delve into the world of electric heavy machinery. For decades, diesel engines have been the cornerstone of construction, mining, and other heavy industries. Despite their power, diesel engines are infamous for their emissions and fuel consumption. They release pollutants, consume vast amounts of fuel, and generate significant noise. Enter electric heavy machinery, a revolutionary shift in the industry. These machines utilize electric motors, which are more efficient and environmentally friendly. Electric motors replace diesel engines, reducing emissions and noise while enhancing efficiency. Traditional diesel engines were loud and polluting, yet they were indispensable for heavy tasks. Electric machinery now performs these tasks with greater efficiency and less environmental impact. This transformation is happening now, not in some distant future. Electric excavators, loaders, and dump trucks are already operational, showcasing their capabilities. Massive electric rigs are powered through external sources, connected with the help of cables, soft starters, and transformers. These components ensure a smooth and efficient power supply, enabling the machinery to operate at optimal performance. Alright, let's pop the hood and see what makes these electric beasts tick. At the heart of every electric machine is an electric motor, or sometimes multiple motors. There are three main types of electric motors used in heavy machinery. Each has its own superpower. The first one is induction motors, or AC motors. These are the workhorses, rugged, simple, and ideal for continuous operations like conveyors and crushers. Next one is permanent magnet synchronous motor. They are highly efficient and compact, used in battery electric machines where energy savings are crucial. Third one is switched reluctance motors. These are gaining traction in extreme environments because they don't need magnets or complex electronics. Think of it as the muscle of the operation, providing the torque and power needed to get the job done. Now let's talk about how to supply power these motors. Powering these motors depends on the application. Here are some common sources. First one is battery pack, which is used in mobile machines like loaders or underground haulers. Next comes the overhead catenary wires used in massive mining trucks. Next, hybrid systems. A diesel engine drives a generator that powers electric motors. Let's go to the huge machineries where power requirements are very high. Cable reels, also known as cable drums or cable management systems, are absolutely essential in massive machines like Bagger 293, bucket wheel excavators, ship-to-shore cranes, and large drag lines. Cable reels are mechanized spools that manage and protect high-voltage power cables or data cables connected to mobile equipment. They're crucial for machines that operate in a limited area but still need constant high-power electricity from a stationary source. A cable reel system allows the machine to move across a mining site while keeping its power line organized, tensioned, and safe from entanglement or damage. These machines are plugged in, literally. They rely on massive cable reel systems to supply uninterrupted power from the grid. As the machine crawls through the mine, the reel winds and unwinds up to several kilometers of high-voltage cable. And this isn't just spooling, it's an engineering ballet. Slip rings ensure electrical contact, tension sensors avoid cable snapping, and guides prevent tangles. Without it, the machine stops, completely. Bagger 293 uses a motorized reel managing up to 6 kilometers of 20 kV power cable. Now let's talk about the brains of the operation, the power electronics and control systems. Inverters and converters manage the power between batteries and motors. These sophisticated components act as the conductor, managing the flow of electricity between the battery and the motor. They ensure that the machine gets the right amount of power at the right time, optimizing performance and efficiency. When you're powering a 100-ton machine, you can't just flip a switch and go full throttle. You need control, you need protection, you need a soft starter. A soft starter is an electronic device used to gradually start and stop electric motors, especially in heavy machinery or industrial applications. It protects the motor and the mechanical system by reducing the inrush current and mechanical stress during startup. A soft starter helps an electric motor ease into motion instead of going from 0 to 100 instantly. You'll find soft starters in some of the toughest places on Earth: conveyor systems in mines, crushers in cement plants, electric bulldozers, bucket wheel excavators, water pumps in hydro power plants, etc. If you just need simple, smooth starting and stopping, go for a soft starter. But if you need speed control, torque control, or energy savings, then a variable frequency drive is the better pick. But hey, sometimes using both together gives you the best of both worlds. Electricity from the power grid is too strong for most machines, plug a motor directly into that and boom, that's where transformers come in. They step down the voltage, like turning a fire hose into a steady stream. Some of the biggest machines, like the Bagger 293, get power through kilometers of cable reels, fed by huge transformers sitting far away. We also need a power distribution unit, which manages and distributes electrical power to various subsystems. At last, Control System, ECU, Electronic Control Unit, integrates all components and manages operation logic. Remember those clunky car batteries we used to lug around? Thankfully, those days are long gone. Electric heavy machinery relies on lithium-ion batteries, the same technology that powers our smartphones, laptops, and even electric cars. But here's the catch. These batteries are bigger, badder, and pack a whole lot more energy. We're talking about high-capacity battery packs that can store enough electricity to power these massive machines for an entire workday. These batteries store enough juice to keep these machines running for a full shift, and when they run low they can be recharged, just like your phone. No more trips to the gas station, no more diesel fumes, just clean and convenient charging. But what makes lithium-ion batteries so special? Well, for starters, they're incredibly energy-dense, meaning they can store a lot of energy in a relatively small package. They're also lightweight, which is crucial for heavy machinery, as it reduces the overall weight of the vehicle and improves efficiency. The secret lies in their chemistry. Lithium-ion batteries use lithium ions moving between the anode and cathode to store and release energy. This process is highly efficient and allows for rapid charging and discharging cycles. Advanced battery management systems ensure that each cell is charged and discharged evenly, maximizing the battery's lifespan and performance. Ever wondered how the battery power is used to run the heavy motors? It's simple. The battery stores electricity, that power goes to an inverter, the inverter sends electricity to the electric motors, the motors turn the wheels or move the arms. The result? Super smooth movement and instant torque, which means the machine starts pushing with full power right away. Here are some real-world beasts powered by batteries. Caterpillar R1700XE, a 100% electric underground loader, Volvo EC230 electric, a battery-powered excavator, Komatsu EV truck, silent and powerful on mine roads. They're already working in mines, construction sites, and ports all over the world. Now, let's dive into the technical benefits of going electric. First and foremost, electric machinery offers significant efficiency improvements. Electric motors are more efficient than diesel engines, converting more energy into useful work. This means less energy waste and more productivity on the job site. And hold on, it gets better. Electric machines are significantly quieter than their diesel counterparts. Remember that ear-splitting roar that could be heard for miles? Yeah, that's a thing of the past. Electric machines operate with a gentle hum, making them ideal for urban environments and reducing noise pollution in sensitive areas. Electric machines require less maintenance than diesel engines. Think about it. No more oil changes, no more fuel filters, no more exhaust systems to worry about. This translates to lower operating costs and less downtime, which is music to any fleet manager's ears. Section 5. Electric Titans in Action Technical Case Studies. Let's dive into some technical case studies showcasing the performance and operational data of these electric machines. Volvo Construction Equipment has been at the forefront, developing electric excavators, loaders, and dump trucks that are transforming the industry. These machines have been tested in real-world applications, from digging foundations to hauling materials, demonstrating impressive performance metrics. Take the Volvo ECR25 electric compact excavator, for example. In urban environments and indoor applications, this machine has shown a reduction in noise levels by 50% and zero emissions, making it ideal for sensitive areas. Despite its compact size, it matches the digging power and performance of its diesel counterpart, with operational data showing a 20% increase in efficiency. The Volvo L25 electric compact wheel loader is another versatile machine. It has been recorded to operate with 30% less energy consumption compared to traditional models, while maintaining high performance and zero emissions, making it a sustainable choice for any construction project. Section 6. The Electric Horizon. A cleaner, quieter, and more efficient future. The transition to electric heavy machinery is driven by remarkable technical advancements. These innovations offer a glimpse into the future of heavy industries, where sustainability and efficiency are paramount. With cutting-edge battery technology and expanding charging infrastructure, electric machines are set to revolutionize the market, transforming our construction methods. Envision a construction site where advanced electric motors ensure clean air, minimal noise, and solar power drives the machinery. This is the promise of electric heavy machinery, a future made possible by technological progress and one worth striving for. Section 7. Technical challenges and solutions for widespread adoption. Now, let's dive into the technical hurdles. The path to an all-electric future for heavy machinery is filled with technical challenges. There are significant obstacles to overcome. One of the primary challenges is the high initial cost. Electric machines have a higher upfront price compared to diesel ones. However, they offer long-term benefits. These machines provide savings through lower operating and maintenance costs over time. Another major challenge is the charging infrastructure. A robust network of charging stations is essential to keep these machines operational. Fortunately, both governments and private companies are investing heavily in this infrastructure, recognizing its critical role in the transition to electric heavy machinery. Section 8. The human element, training and empowering the workforce. Now let's talk about the people behind the machines. The transition to electric heavy machinery requires a skilled workforce, folks who understand the ins and outs of this new technology. We need to invest in comprehensive training programs that equip workers with the knowledge and skills they need to operate, maintain, and repair these machines. This involves hands-on training with the machinery, understanding the software and control systems. It's about mastering the principles of electricity, battery technology, and power electronics. Workers need to be adept at troubleshooting, diagnostics, and implementing sustainable practices in their operations. Section 9. A sustainable legacy. Building a better future with electric heavy machinery. At the end of the day, the shift to electric heavy machinery is driven by groundbreaking technical innovations. Advanced battery technologies are enabling longer operational hours and faster charging times. Research is focused on enhancing energy efficiency and integrating renewable energy sources. Future trends include autonomous electric machinery and smart construction sites. These innovations are paving the way for a cleaner, quieter, and more efficient future. Let's get to work, folks.